Hey everybody, welcome back to another fun and exciting Algebra 2 class. We're going to continue in Chapter 8, Lesson 1. Finish up the lesson here. We're talking about triangles in this part of the lesson. We are on page 377, 377. All right, let's just jump right down into it and just kind of complete our thoughts from the last part of the lesson. Last lesson we were talking about angles, and now we are talking about triangles. What's the difference? Well, angle is just one, triangle, there's three of them. And there's three of them that are connected into one shape. If you look down on the screen, I have a picture of a triangle there. Interesting fact about triangles is that they always add up to the sum of the angles. Always. I've got that, uh, you know, in underlined right there. That's important right there. So I underlined it. They're always equal to 180 degrees. In other words, what do I mean by that? Well, let's say that this one equals 80 degrees and this one equals make this 70 degrees. Okay? So the question is, what does this one equal? Well, the way that you would do that is you could do it several different ways, but you do 180 minus 80 minus 70. Okay, or you could do 80 plus 70 subtracted from, well, actually, my subtracted from needs to come over here, 180 minus that. You could do that too. I just like to subtract them all. It makes it a little bit easier for me. So 180 minus 80, that's 100 minus 70. That means that this angle down here, the missing angle, is 30. So you just work your way around it. You can add them up, then subtract from 180. But the key is this 180 degrees. It's always equal to 180 degrees. Even in a right triangle, this one is a right triangle. Now, interesting thing about a right triangle is all we need and here's the thing that tells you whether or not it's a right triangle. Whenever they put this little thing right there, it looks kind of like a little chair or something that you could sit in. All right, it's a little square right there. And when you put that there, when the book puts that there, when somebody puts that there, that means that this is a right angle. That's what that little square means. Or what does it mean? It means that it's 90 degrees. So when we have this, here's what else that means. Every right triangle is 180 minus 90. So every right triangle means that these two angles have to equal 90. In other words, all we need is one of these. Let's say that this one's 30. Well, we automatically know that this one has to be 90 minus 30. This one has to be 60 degrees. Okay? Because the total is 180, so the right angle is 90, so we only have 90 more between these two angles. So a little shortcut there with right triangles. All right, if you will go ahead and turn the page in your book, we are on page number 378. 378, right at the very bottom. It's called right triangle setup. I think it's a little crazy that they call it right triangle setup and then they don't give you a right triangle, right? They give you it looks like an equilateral triangle right there. But it's definitely not a right triangle. So I don't know why they do that, but I am going to just skip that one and let's just go to the next page where they do give you right triangles. Look down there on page 379 and you'll see a picture of a right triangle. And let's use the one that has where it says leg, hypotenuse, leg, ABC. Let's use that one. It's in the middle of the page. So let's take our picture here on the screen and let's start filling it in. The book says that this right angle is C. Now don't forget that that right angle will always have one of those, and that will signify that that is the right angle. In geometry and in trigonometry, you almost always, unless you have more than one angle, more than one triangle, you almost always call the right angle C. Okay, we're almost always dealing with that as C. You might call it something else and it's okay, but many, many times you're going to see that right angle be labeled C. Now, let's go ahead and talk about the other ones. It doesn't matter if I put A here or A here. It doesn't matter which one I make A. The one in the book, they made A this top one. and it's fine. You can make A whichever one, and then that would make this one B. Okay, so you have A, B, and C. Now, across from the angle, so for instance, across from the letter C, the angle C, is the small letter C. That's how we name the sides. Across from this capital letter A angle, we're going to name this one small letter A. Across from angle B, we're going to name this one side B. So ABC, and then that's the angles, and then across from the angles is small letter ABC, and those are the sides. Okay? Now, when we're talking about sides in a right triangle, the C side, this is the one opposite of the right angle. This one's always called the hypotenuse. The hypotenuse. Maybe you've heard that before and you've always wondered what in the world that is. But it's the hypotenuse, right? Across from the C, across from the right angle. One thing is true about every right angle. The hypotenuse is always across from it. Okay? You can never have a hypotenuse connected to the right angle. Then these other ones are called legs. So that would be a leg, and this would be a leg. Okay, I put legs. I don't know why I put legs. There, it's just leg. That's a leg, and that's a leg. And we would call this leg B, and we would call this one down here leg A. Leg A and leg B. So yeah. Next interesting thing that we need to know about these. Let me kind of shrink that down a little bit so you can see it a little bit better. I'll change my color on my pen so you can see this. We're going to use we're going to use the word reference angle. A reference angle. Here's what a reference angle is. The reference angle is the angle that we're talking about. Okay? If I say angle A, then angle A is the reference angle. In geometry, in trigonometry, this is how we signify the reference angle. We put like a little arc right there, a little curve, okay? And so if I'm talking about angle A, I put a little curve arc on the angle, so I know I'm talking about angle A. Let's scroll down here and look at these. Hypotenuse, the side across from the right angle, I already told you that. Legs, the non-hypotenuse sides. So look, the legs, this is the hypotenuse, then this is the leg, and this is a leg. Okay, the non-hypotenuse sides. The next thing is this word opposite. What does that mean? Well, you see it says the leg across from the reference angle. Okay, what's the reference angle? I just told you what the reference angle was, all right? The reference angle is whatever angle I'm talking about. I'm talking about angle A. So that's the reference angle. Well, the opposite. So what is opposite of A? Okay, leg A. Leg A. That is the opposite. So this would be, in this case, A would be the opposite. The next thing is the adjacent. Now, we learned what adjacent meant last class, but it means something just a tiny bit different here in the triangles. But it means really the same thing. This is the adjacent leg. Why is it adjacent? Because it's adjacent to the reference angle. So there's my reference angle, and the adjacent leg is the one that's connected to my reference angle. Notice the opposite is not connected to angle A. The opposite is not connected to it. What is connected to it? This is called the adjacent. Adjacent, okay? That is in reference to angle A. Now, I need to show you something that hopefully does not blow your mind. Now, I'm going to change my reference angle to B. Now my reference angle is B, so I come down here to B and I put my little arc on B. Guess what else changes? Now this is the opposite, and this is the adjacent because it's connected to my reference angle. So now this is the adjacent. So depending on which angle you're looking at, the opposite and the adjacent can change. Here's what can't change. The hypotenuse can never change. The hypotenuse is always across from C. The opposite and the adjacent can change. Based on what? Based on the reference angle. Okay, in this case, we were looking at B. So we needed to focus on B. In the last case, we were focused on A. So we looked at A. So depending on which reference angle you're talking about, the opposite and the adjacent can change. The hypotenuse never changes. It's very important to remember that. All right, continuing on in the book, we are on page number 380. Page 380. Similar shapes, similar polygons, the book calls it, similar triangles. That's what we're working on right now. So similar shapes. What is a similar shape? Here's what it is. And on page 381, there's a little chart. There's a little, they call it, there's a little box there. It says similar triangles. Okay, so look at that as we're going through this. Same shape, but different size. Okay, same shape, but different size. So if you look at these two triangles that I have, they are the same shape. In other words, they're both right triangles. Everything about them is the same, except for one thing. One of them is bigger. Okay, the one here on the left is bigger than this one on the right. But other than that, they're the same. Everything's the same. Notice it says all corresponding angles are the same. Well, what does that word corresponding mean? That's important to understand that word. It's a new word. We haven't used that word before. So what does this word corresponding mean? Here's what it means. Let's call this C because that's the right angle. Okay. We'll call this A and we'll call this B. Well, in this one, let's call this C with a little tilde mark. We'll call this A with a little mark, and we'll call this B with a little mark. Okay, we're just like saying that C1 and this is C. So we're just kind of putting them the same. We could call them X, Y, and Z. We could call them whatever we wanted. But here's what I want to draw your attention to. Notice that C corresponds with the C with the tick mark. C corresponds, and that's this right there. We'll get that in a little bit, but C is corresponding to or similar to C tilde. Okay, corresponding. What does that mean? It means that if you kind of put them on top of each other, then they would match, right? They would match up. Notice that it says, let's go back to our definition up here, all corresponding angles are the same. So in other words, C is 90, then this C is 90. Let's say that A is 45. This A would be 45. And let me use something different than 45 because that would make everything the same. This A is 40. This A is 40. Okay? And that would make this B 50. And this B would also be 50. All the corresponding angles are the same in similar shapes. Notice that it says the corresponding sides are proportional. The corresponding sides are proportional. What does that mean? Here's what it means. If this side is 4 and this side is 3 and this side is 2. I'm just using some examples. Then the corresponding sides are proportional. What does that mean? They're in proportion with each other, or they're equal but proportionally equal to each other. So that means that if this side is 8, here's the way that you would figure this out. So what is this and what is this? That's what we want to know. If I tell you that that side's 8. Well, let's make a proportion with these two things. What does that mean? 4 over 3 is equal to 8 over what? Do you remember how to do this? Okay. Remember, we would multiply here and multiply here. This is an algebra problem. So what does that look like? 3 times 8 equals 4x. 3 times 8 equals 24 equals 4x. Divide both sides by 4, and so that would be equal to 6. Okay? And so this side, this missing side that we had right down here, would be 6. Why would it be 6? Because it's corresponding and it's proportional to these ones. So now let's find this one. Let's find this missing side. We can do it again with these numbers here. So 4 over 2, and then 8 over, we don't know. Again, we do the same thing, set it up algebraically. So this time I'll just do 4x on this side equals 2 times 8. 4x equals 16. Divide both sides by 4, and we would get x equals 4. So that missing side over here would be 4. So we solve it proportionally. If you don't remember how to solve proportions, then you need to go back and you need to kind of brush up on those proportions. But basically, proportion just means that the two things are equal, but they're equal based on the proportion or the size difference between the two. They're proportionally the same, okay? Which means that their fractions are going to be equal. They're going to have equivalent fractions. Remember, in fractions, we always do this. In proportions, we always do that's the means, and that's the extremes. So the extremes equals the means. So just set it up like an algebraic proportion problem. Multiply it out, divide it, boom, you got the right answer. All right. Well, I think that's all I have for you. Yeah, scroll down and that's it. So that's all I got for you. I hope you learned something today. Make sure you rewind that and watch it again if you missed anything. And hope you all have a good day. Bye-bye.